Last night we spent some time talking about the key values that nurses need to be looking at when they are going to analyze blood gases. So let's apply that to a nice normal blood gas. 730, 56, 20, 76, and -2. Primarily, we want to focus on the pH, the CO2, and the HCO3 or the bicarb. So pH, carbon dioxide, and bicarb. Let's look at each one and analyze what is happening. The pH is 7.30, which we would consider normal. The CO2 is 56, which, yes, is on the high end of normal, but in our NICUs, we would consider this normal, also depending on what's going on with the baby and watching trends. And we have a bicarb of 20, which we would also consider normal. So we would consider this a normal blood gas. Are there things that we need to be watching? Yes, both the pH and the CO2 are borderline. This would depend on what your baby's story is. So let's go through and kind of define what each value tells us. So if we want to know if our baby has respiratory acidosis, we would look at our pH being low, our CO2 being high, and our bicarb being within normal limits. Now we are talking basic understanding. We are not investigating into our compensation yet. So these are just primary acid-base disorders. When we talk about respiratory alkalosis, we would have a high pH, a low CO2, and again, a normal bicarb. When you think respiratory, we're going to circle that in red, we are looking at our CO2s to be abnormal. So if your only abnormal value between your CO2 and your bicarb is your CO2, we know that that's respiratory. So now let's talk about what metabolic acidosis would look like. So with metabolic acidosis, again, acidosis means you don't have enough acid, it's too low. So our pH would be low. Our CO2 is going to be within normal limits, and our bicarb is going to be low. With metabolic alkalosis, right, your pH is going to be high, your CO2 is going to be normal, and your bicarb is also going to be high. So here we see metabolic goes with abnormal bicarbs. This is the idea of where Rome comes from. So it's ROME, respiratory, opposite, metabolic, equal. So that means respiratory opposite is your pH is low and your CO2 is high. In metabolic equal, if your pH is low, your bicarb is low. So that's what Rome is. I did not learn that in nursing school, but we talked about, is there one thing that way you like to learn something? Rome is one of those ways. So let's apply this to a baby. So if we have a gas of 715, 66, 20. Again, what our 715 is low, our CO2 is high, and our bicarb is within normal. It's not great, but it's within normal. So we have a low pH and a high CO2. So if we were looking at Rome, so it's respiratory is going to be opposite. So this would be respiratory acidosis. We have a new 26-weeker on a ventilator with a rate of 40. Let's look at each number. Our pH is high, our CO2 is low, and our bicarb is within normal limits. So our pH, again, is high. Our CO2 is low. So bicarb normal, that tells us they're opposites. So if we do the Rome, we know this is going to be respiratory. And because our pH is high, this is going to be alkalosis. So this would be respiratory alkalosis, essentially meaning we are overventilating. So in order to fix that, we would want to work on our rate or our pressures, depending on what mode of ventilation your baby is on. So let's just take that to a few more examples of what's going on here. Doesn't want to go to the next slide.